Hello, 5th graders, and welcome to today's read aloud of our science ebook for the day titled Earth's Cycles, as needed for today's science lesson, Unit 5, Lesson 5, called Earth, Moon, and Sun. So the opening question asks, why do the moon and the sun appear to move around the Earth? Let's read to find out, reading pages 4 through 29 of the ebook today. So let's open her up. Move on to page 4. Here we go, starting with Chapter 1, Cycles Make the World Go Round. A frog lays a mass of eggs. Before long, the eggs hatch and become tadpoles. The tadpoles grow legs and become froglets. Eventually, the froglets become full-grown adult frogs, which lay eggs of their own. These new eggs hatch into tadpoles, which become froglets that grow into adult frogs, which lay eggs, and so on. This is an example of a cycle. A pattern of related processes or events that happen over and over again. Like a circle, a cycle has no beginning and no ending. It just keeps going and going and going. Cycles of life. Every day, Earth is filled with many cycles. In fact, every day is a cycle, which we divide into units of hours, minutes, and seconds. These units of the clock help us measure our time within the daily cycle as we go to school, relax, and do homework, and sleep at night. Then in the morning, we awaken and rejoin the daily cycle. Many cycles happen so regularly and constantly that we don't even think about them. The passing seasons, the phases of the moon, rising and falling tides, these are all connected to the sun's energy and gravity, and to Earth's place in the solar system. They are never-ending patterns that affect the lives of all living things. Sun and moon. Every day, Earth rotates or spins on its axis, creating day and night. Every year, Earth makes one full trip or orbit around the sun. At different times of year, different parts of Earth are tilted more towards the sun and receive more direct sunlight than other parts of Earth. Seasons come and go. Meanwhile, the moon orbits Earth about once a month. It sometimes shines as a bright full moon, and sometimes appears nearly completely dark and invisible without the aid of a telescope. All these cycles have been happening as long as our planet and its moon have existed, and they affect life on Earth every day. Humans can't change how these cycles happen, but if we understand how they work, we can better control how they affect us and other living things. For example, we use our knowledge of Earth's cycles to predict the weather. We also use our understanding of these cycles to figure out when to plant crops. We now use sunlight and the rising and falling of ocean tides to generate energy. In these ways, we have begun to harness the power of the sun and the moon to provide new forms of energy for life here on Earth. Chapter 2, You Are Here, on Planet Earth. In the late 1990s, TV viewers were entertained by a comedy called Third Rock from the Sun. The show was about aliens from another planet living on Earth. The aliens thought Earth was a boring place, nothing more than, well, the third rock from the sun. They were right about a couple of things. It's true that Earth has a hard, rocky surface, although that surface is largely covered with water. It's also true that Earth is the third rocky planet from the Sun. Mercury is the closest rock to the Sun, followed by Venus, then Earth, and then Mars. The aliens on that TV show were wrong, though, about Earth being a dull place. We know this planet is extra special because it's the only one in this solar system that we know for sure can support life. Life support. Earth is part of a system called a solar system. Scientists believe our solar system was created about 4.5 billion years ago. It is made up of 8 planets that circle or orbit around the sun, each staying in its own path. So there's the sun right there, and there are the orbits or big circles for each of the 8 planets in the solar system that orbit around it or go around it in big circles. In order, from closest to the sun, are the planets Mercury, Venus, Earth, that's where we live, Mars, Jupiter, Saturn, Uranus, and Neptune, the farthest one. Between Mars and Jupiter is the asteroid belt. This is a ring of rocky bodies or asteroids left over from the creation of the solar system. There are millions of asteroids in the solar system, and most of them are here. Beyond Neptune is another donut-shaped area in space. It is called the Kuiper Belt, and it extends for billions of miles beyond Neptune's orbit. It is filled with millions of icy objects and comets held in orbit by the sun's gravity. Surrounding this whole system is another, even larger area called the Oort cloud. This is a sphere-shaped region that extends almost 2,000 times farther out into space than the Kuiper belt. The Oort cloud may contain more than 1 trillion icy bodies of different sizes. Of the planets in the solar system, Jupiter is the largest, Mercury is the smallest, Earth is the 4th smallest, and it's the only planet that is home to animals, plants, and other living organisms that thrive on our planet. That's because Earth has liquid water and a temperature just right for supporting life. Earth is also the right distance from the Sun to receive just enough, but not too much, heat and light from the Sun. Venus, for example, is too close to the Sun to support life. It is so hot on Venus that water would boil away, and plants and animals would burn to death. Mars, on the other hand, is too far from the Sun. Any water on that planet is frozen under polar ice caps. It is so cold on Mars that no living thing we know of could survive there. On Earth, the Sun's energy provides just the right amount of heat for water to exist, mostly in a liquid state, and all plants and animals need water to survive. The Sun's energy also powers a process in plants called photosynthesis. Learned about that before. In this process, plants take in water from the soil and carbon dioxide from the atmosphere. Using energy from the sun, they convert those substances into sugars and oxygen. The sugars feed the plants, and the oxygen is released into the air. That oxygen is what nearly all of Earth's animals depend on to stay alive. Tilt and spin. While the Earth travels in its orbit around the Sun, it is also spinning on its axis. So think of the Earth spinning like a top, spinning around and round in circles. The axis is an imaginary line that runs through the Earth from the north to the south poles. Earth makes one full rotation on its axis every 23 hours and 56 minutes. We call that a day, and we round it up to 24 hours. As our planet spins on its axis, we experience daytime and nighttime. The way Earth is tilted on its axis, along with its position in its path around the Sun, also determines how much light different parts of the planet receive at different times of the year. The equator is an imaginary line that circles the middle of the Earth like a belt. For places near the equator, the amount of sunshine doesn't change much from day to day or month to month. Places in the north and south of the equator, though, experience different amounts of sunshine at different times of the year. Whether it's night or day, winter or summer, the sun plays the most important role in the existence of our planet. Let's take a closer look at the cycles of Earth and how the sun impacts life on this rock of ours. Chapter 3. Sunrise, Sunset, Seasons. Scientists believe that the Milky Way, our galaxy, is one of more than 100 billion galaxies in the known universe. Based on estimates of hundreds of billions of stars in each galaxy, this makes the Sun one of an estimated 300 sextillion stars in the known universe. Using numerals, that figure looks like this. That will be 3 followed by, 3, 6, 9, 12, 18, 21, 24, 25, 26. 3 followed by 26 zeros. So our Sun is just one of that many stars in the known universe. Of all these stars, the Sun just happens to be our star, the one that brings Earth to life. Because it is so important to human survival, ancient peoples worshipped the Sun. They believed the Sun was a god, and they wanted to keep that god happy. In some countries, they held ceremonies to honor the Sun. They danced, sang, and made offerings to the Sun. The idea was to encourage this great god to bring good weather and healthy crops to the people. Today, we know a lot more about the Sun, its relation to Earth, and its importance to life on Earth. Spotlight on the Sun. The Sun is huge. It is more than 1 million times the size of Earth. And Earth is already pretty big. It would take 109 Earths laid side to side just to make a single line across the face of the Sun. The Sun is so big that it contains 99.9% of the total mass of the entire solar system. The remaining 0.1% is made up of all the planets, moons, asteroids, comets, dust, and gas in the solar system combined. It's no wonder that this star has so much influence on Earth. The Sun's massive gravity holds Earth and all the planets in orbit. The Sun also influences weather patterns and climate zones on Earth. It gives us both the seasons and day and night. We know that every 24 hours, Earth makes one full rotation on its axis. When the place where you live faces the sun, you have daylight. So on this part of the sun that's facing the sun right now and getting sunlight, it's daytime for those people there. But when it faces away, you're in the dark of the night. So when when the Earth rotates and you find yourself on this side of the Earth, facing away from the sun, in the shadow, that means it's nighttime for you. During the day, the spinning of Earth makes it appear that the sun rises and sets and moves from east to west across the sky. It also appears at night that the stars travel through the sky. We know that the sun and the stars don't actually move in relation to Earth. It is our planet, and with it, us, that are moving, or us with it that are moving. Earth's rotation makes it look like the sun and other stars are traveling through the sky. There was a time, though, up until about 350 years ago, that people thought it was the other way around. They thought the Earth stood still, and that the sun moved around where the sun appears in the sky. It isn't just Earth's rotation on its axis that changes the sun's position in the sky. Earth's tilt and orbit also change where the sun appears to be above us. Earth always tilts in the same direction. This means that as it travels around the sun, it sometimes tilts towards the sun, and sometimes it tilts away from the sun. And it is that tilt that ends up causing the seasons to happen on different parts of the Earth at different times of the year. If you live in the northern hemisphere, the sun is tilted more towards the sun during late June, July, August, and early September. For the record, we in the United States are in the northern hemisphere, so June, July, August, and early September would be summertime for us. That means places north of the equator are closer to the sun, or more tilted more directly towards the sun, and warmer at that time of the year. That's why it's summertime for us. At the same time, the sun also appears to climb higher in the sky, and the days are longer. This is summertime in the northern hemisphere. Summer in the southern hemisphere, so that would be places further south, below the equator, like maybe Australia or South Africa. Summer in the southern hemisphere happens from mid-December to mid-March. So when it's winter time for us in the northern hemisphere, it's summertime for them, and vice versa, the other way around. That's when the northern portion of Earth is always tilted away from the sun. This means that points south of the equator are closer to the sun at that time. When the days are long and the sun is high in the sky in the south, the northern part of the Earth experiences shorter, colder days, meaning winter. So summer in the northern hemisphere, that would be when the northern hemisphere is more pointed directly at the sun, so we're getting more direct sunlight, longer days, warmer temperatures, summertime. Whereas on the southern hemisphere, they're tilted more away from the sun, so they're getting less direct sunlight, their days are shorter, that's why they have wintertime at the same time. But at the opposite end of the year, the northern hemisphere is facing away from the sun, or is tilted more away from it, so we're getting less direct sunlight, shorter days, that's why we end up getting wintertime. Or at the same time, the southern hemisphere is now facing more directly towards the sun, more direct sunlight, longer days, therefore warmer temperatures, summertime for them. In both hemispheres, when Earth is between summer and winter, it is autumn. The hours of daylight and darkness on our planet are never exactly the same, but they become more equal at this time of year. The same thing happens in spring, when Earth is between winter and summer. Zoning out on Earth. Every part of Earth actually has different seasons, but in some places it doesn't feel that way. Different parts of the planet are in different climate zones. In North and South Poles, for example, are in the polar zone. There it is dry and ice-covered all year round. It's also freezing cold all year round. That's because the sun's rays always strike these polar zones at an angle. The light there is indirect, or less focused, than the sunlight that reaches other parts of the planet. This indirect sunlight is also cooler than the direct light that strikes Earth at the equator, for example. So even though there are changes in temperature between summer and winter in the polar zones, you can be sure it's always cold. In terms of sunlight in these two regions, however, there are two dramatically different seasons. At the North Pole, in the summer months, the sun is above the horizon and shines 24 hours a day. That's because this pole is pointed toward the sun. On the other hand, during the winter, the sun is below the horizon and doesn't rise for weeks on end. That's when the North Pole is tilted away from the sun, and it's in the shadows. The same thing happens at the South Pole at opposite times of the year. When it's winter at the North Pole, it's summer at the South Pole. As you travel away from the poles, toward the equator, you pass through another climate zone. This one is called the temperate zone, and it includes nearly all of the United States, most of Canada, plus Europe, northern Asia, and the southern part of South America. So you can see in that picture right there, the North Pole, during the 6 months of the year where it's facing more towards the sun, you can have a very long time where the sun never sets. It's almost like the sun is in the sky for the whole 6 months. Whereas the opposite 6 months of the Earth, or the opposite 6 months of the year, you would have the North Pole facing away from the sun, which is kind of what's happening with the South Pole here. It's completely facing away from the sun, and so for those same 6 months, it's facing away, and so the sun never rises. So it's almost like a 6-month-long night. People in the temperate zone experience 4 clear seasons, with noticeably different temperatures and weather conditions in each season. Places in the world that are near the equator are in the tropical zone. Here, the sun is closest to Earth and shines most directly on Earth all year long, and it is hot all year round. Still, there are 2 distinct seasons, a rainy season and a dry season. Energy from the sun drives cycles of wind and air pressure that determine when the wet and dry seasons occur each year. In the tropical zone south of the equator, the rainy season takes place, from October to March. North of the equator, the rainy season happens from April to September. Day and night, seasons, weather, and climate. All these cycles are connected to Earth's relationship with the sun, and this relationship is connected to 2 very important cycles, our Earth's rotation in its axis and its orbital path around the sun. Meanwhile, the moon is responsible for some earthly cycles of its own. Chapter 4, Moonstruck. Just as some ancient cultures worshipped the sun, many also worshipped the moon. Some ancient peoples believed the moon was a god, goddess, or spirit sent to help them or protect them. Because it is the largest and brightest object in the night sky, the moon has also inspired many myths and legends. It is often connected with motherhood, wisdom, birth, death, the afterlife, and madness. The word lunatic, to describe a person who is mentally ill, comes from the word Luna, the name of the Roman goddess of the moon. You may also know Luna as Spanish for moon. Even today, some people believe a full moon makes humans do strange things. According to some legends, they might even turn into werewolves. Of course, that's just a legend, that's not real, but still. Interesting to see the connection there. Phasing in and out. Without the sun, we would not see the moon. The moon does not give off its own light. Instead, it reflects the light of the sun back to Earth. Sometimes the moon appears as a big full circle in the sky. That's called a full moon, and it happens when the sun is positioned, or the moon is positioned so the sun lights up the entire face of the moon as we can see it from Earth. The full moon appears in the night sky every 29.5 days. This time period from full moon to full moon is called a lunar cycle or a lunar month. The lunar month isn't quite the same as a calendar month. Sometimes, in fact, there are 2 full moons in one calendar month, one at the beginning of the month and the other at the end. This is called a blue moon, even though it's not blue. In some traditions, full moons were often given names, such as pink or strawberry moon, depending on when they occurred. Blue happened to be the name given to the place in the cycle of full moons when this extra full moon occurred. It also gave birth to the expression, once in a blue moon, to describe any event that rarely happens. As Earth orbits the sun and the moon orbits Earth during a lunar month, the moon appears to take different shapes in the sky. So we've got a full moon there when the entire face of the moon is lit up by the sun, and then we have like waning moons, half moons, and crescent moons, when part of the moon is being covered by the shadow of the Earth. The size and shape of the moon we see depends on how much of the sunlit side of the moon is visible from Earth. These different shapes are called the phases of the moon. There are 8 phases. The full moon is 1 phase. Halfway between one full moon and the following moon is a phase called the new moon. This happens when the moon is on the same side of Earth as the sun. At this time, the sun shines on the side of the moon facing away from the Earth, with almost no light on the side facing Earth. That means the moon appears completely dark and is invisible except through a telescope when viewed from Earth. So if we look at this model showing the different phases of the moon, we have a full moon here where it's on the opposite side of the Earth from where the sun is. If the sun is over here, the Earth is here. If the moon is on the opposite side and it's fully illuminated by the light of the sun, we can see the whole thing, therefore we call it the full moon. On the other side of the cycle, though, if the moon is between the Earth and the sun, then we're only seeing the shadow side of the moon, and therefore it almost appears invisible, so we call that a new moon. After the new moon, the moon appears to get bigger every day as it approaches the full moon phase. When the moon is increasing in size, it is called a waxing moon. The waxing moon passes through 3 phases between the new moon and the full moon. These phases are called waxing crescent, first quarter, and waxing gibbous. A crescent moon appears as a sliver of the moon. A gibbous moon is almost a full moon, with just a sliver of the moon in the darkness. So from where the full moon is, as the moon continues to revolve around the Earth, more of it appears to be lit up by the sun, and still we start to get to see a little bit more of it each time. So from a full moon where the moon is almost completely in shadow and we can't see it, a little bit later, maybe a week later, we start to see a waxing crescent moon, where we start to see a little bit more of the moon lit up. About a week after that, when about half of the moon is visible, we would call that the first quarter moon. And then whenever we get to about maybe 3/4 of the moon visible, almost a full moon but not quite, that's where we have a waxing gibbous. Finally, about a week later is when we'd see the full moon. So continuing on, as the moon appears to decrease in size from full moon to new moon, it is said to be waning. So that's from full moon back to new moon, we start to see the moon slowly start to become less visible. The 3 phases of the waning moon are the waning gibbous, the third quarter, and the waning crescent. So as the moon rotates around or revolves around the Earth, that's the phases of the moon that we'll see over the course of a full month, typically. Rising and falling. The sun's gravity keeps Earth and all the other planets in our solar system in orbit around the sun. Earth's gravity keeps the moon in orbit around Earth. The moon also has gravity. It's not as powerful as the gravity of the sun or even Earth, but it does have an important effect on our planet. About 70% of Earth is covered with oceans. It is primarily because of the pull of the moon's gravity that those oceans have rising and falling tides. The moon's gravity tugs the surface of Earth slightly toward the moon. Because Earth is covered in liquid water, and water moves fairly easily, the moon's gravity pulls the water into bulges. The part of Earth facing the moon experiences the greatest pull of gravity. Therefore, that part has the greatest bulge. As Earth rotates on its axis, this bulge of water, which is called a high tide, moves around the globe. So we can see that in this visual right here. That green circle is the Earth, and the blue surrounding it is our oceans, and there's the moon. So what happens is that the moon's gravity will actually pull or tug on the Earth's oceans and actually cause them to rise or bulge out towards the moon. And it even happens on the other side of the Earth as well. So these 2 parts of the Earth right here, where the oceans are being bulged out by the moon's gravity, we call those high tides where that's happening. Most places on Earth have not 1 but 2 high tides each day. That's because the water on the side of the Earth furthest from the moon also experiences a tidal bulge, like over here. This tidal bulge on the far side of Earth from the moon is due to several forces acting on our planet. One of them is called centrifugal force. So what is centrifugal force? It's explained here. Imagine you are spinning on the spot, with both hands holding onto a rope, tied to a bucket with water in it. You're spinning fast enough for the rope to extend away from you, and the bucket circles around with you. Centrifugal force is what makes the bucket pull at the end of the rope. It also makes the water push against the bottom of the bucket, as the bucket flies in a circle around you. In a similar way, as Earth is spinning on its axis, centrifugal force pushes ocean water away from Earth's surface. This creates a tidal bulge on the side of the Earth that is farthest from the pull of the moon. This would be the side where the pull of the moon's gravity is weakest, and the effects of centrifugal force greatest. Also, the moon's gravity is pulling at Earth and tugging the surface of that side of the planet away from the water and toward Earth's center. This also has the effect of increasing the tidal bulge on the far side of the Earth. The moon has the greatest impact on Earth's tides, but the sun's gravity also affects them. The highest tides occur when the sun and the moon are in line with each other, like in that picture right there. The sun and the moon are in line with the Earth, therefore the gravity of both the sun and the moon are pulling on the Earth's oceans. That causes the highest tides. So the highest tides occur when the sun and the moon are in line with each other during the days of the full moon and the new moon. Cycles of time. Before the invention of calendars and clocks, ancient peoples looked to the sky to measure the passing of time. They realized that the rising and setting of the sun was a pattern that happened over and over again. They also noticed that even though the look or phases of the moon changed from day to day, the pattern of the moon's phases regularly repeated itself. Ancient peoples also saw that the sun followed a path through the stars in the sky, eventually returning to the point where they believed it had started. These repeating cycles became the basis for calendars. The time between sunrises came to be known as a day, the time between full moons came to be known as a month, and the time it took for the sun to make its full journey through the stars was known as a year. Early calendars were based on the lunar month, or 29.5 days. The problem was that the solar year, the sun's cycle, was 365 plus days. A solar year didn't divide into an even number of lunar months. 12 lunar months total only 354 days, while 13 lunar months total 383 days. To account for this variation, some early calendars alternated between 12-month years and 13-month years. Others alternated between 29-day and 30-day months, with an added month every few years to keep the moon's months and seasons in line. Some calendars used 12 lunar months and just ignored the extra 11 days. The calendar we use today is based on the Julian calendar. This calendar got its name from the fact that it was created 2,500 years ago during the reign of Julius Caesar of ancient Rome. In that calendar, every month had 30 or 31 days. February usually had 29 days, with 30 days every fourth year. So this is very much like the calendar we have today now. After about 1,500 years of using the system, though, the calendar year and the true solar year no longer matched up. They were off by about 10 days. The calendar was shifted to make up the 10 days, and February became a 28-day month, with 29 days every fourth year, which we call a leap year, from then on. This calendar is the one most countries use today. It is called the Gregorian calendar. Some cultures still use the Julian calendar, and it is currently about 13 days behind the Gregorian calendar. So that was the ebook on Earth's cycles, everybody, at least up to page 29. Thank you for joining me today. We'll see you for the next one. Take care. Goodbye.